In this brief video, I'm going to show you how to calculate the present value of a single payment. Calculating the present value of a single payment is very useful for determining the worthiness of a particular investment. We know that because the time value of money, that $1,000 today is not worth $1,000 4 to 5 years from now because we incur a number of different risks. Not only do we incur inflationary risks because the prices of goods and services continue to rise and our spending power is thus limiting because the number of dollars that we have is remaining the same, but we also know that we incur opportunity cost risks because we are foregoing what we could do also with that $1,000, our investments, purchasing a number of different alternatives. And so we know that the money is not worth the same thing, so how do we get that to the point to where we can compare them and make a very accurate determination as to whether the investment is worthy or not? So let me give you a quick example that we can solve from a quantitative standpoint so we can shed some light on this particular issue here. Let's go ahead and assume that a friend of ours wants to borrow $1,000 today. And this person promises to pay us back $1,500 3 years from now. So just a quick analysis may lead you to believe that this could be a really good investment for the most part. We're benefiting $500 from this transaction, all from simply not touching our money for about 3 years, which may be pretty good. Unfortunately, though, we can't compare these because we're evaluating $1,000 in present day to $1,500 3 years from now, and we know those aren't the same. So how do we put them on a level playing field to the point where we can essentially analyze those? What we'll do is we'll determine what the present value is of this future payment, essentially. So we have to discount that $1,500 into today's dollars. So there's a brief equation to show you how to do this. So first off, let's map out what we know presently. So we know that we're guaranteed $1,500 as a future value. So this is what we're going to receive 3 years from now. We know that our money is locked up for 3 years, so N is going to be 3 years. The next thing we have to do is determine an interest rate. And usually how this works is we try to assess what is a relatively safe investment. If we had this $1,000 in our possession, what interest rate could we earn on it had we invested it? And so let's assume, just for sake of argument, that we could have earned about 5% on this particular investment. Okay. And obviously we need to solve and figure out what the present value is. That is the unknown variable that we're trying to solve. Now how this would work graphically is I'm going to go ahead and draw a quick line here, put some hash marks, and let's assume these are periods 0, 1, 2, and 3, of course, and we're earning 5%. This is what we're going to discount our payment from, and we're earning in year 3 $1,500, but obviously we need to go ahead and discount that and find out ultimately what it's going to be worth today. So there's a brief short equation that can help us determine ultimately how to solve this particular problem. And that equation is PV, or present value, equals the future value divided by 1 plus our interest rate, which is shown as little I, to the nth power, of course. And so if we're going to solve this particular equation, what we do at this point is plug in the existing variables that we know and we solve for our unknown variable. So we know that FV, of course, is 1,500. And 1, of course, plus 0.05 is 1.05. We have to convert the interest rate to decimal form for the equation to work. And to the third power, 1.05 to the third power, that number actually comes out to 1.157625. And I'm going to keep this in its present form. I'm not going to round at this point because that ultimately can throw off the end result. We'll, of course, round to the nearest hundredth decimal place once we have the final result here. So if we divide 1,500 by 1.1576250, what that does is that gives us a present value of actually $1,295.76. And so how this would work is essentially if we were to invest $1,000, okay, and we were to receive $1,500 3 years from now, okay, discounted in today's dollars, that $1,500 is actually worth $1,295.76. So this would be an actually good investment here, because all we're doing is we're putting in $1,000 initially, but we're getting back $1,295.76. And so really, we're actually benefiting $295.76 from this transaction, in addition to that 5% interest that we could have earned on the $1,000. And so the way you would evaluate this is, this obviously would be a good investment to make, assuming that we would just have been able to earn 5%. Not only are we earning that, but we're earning an additional $295. So you can argue we're earning upwards of maybe 10, 11% on this particular investment. So this would be an example of how you could use this particular equation to assess ultimately if you're going to receive some type of payment in the future. Is it worth it when you translate that in today's dollars due to the time value of money?